So it's really nice to have you all here. And this webinar will be recorded and shared later via INGENIUM web pages, like I said it already. And you are most welcome to join this special edition of the Staff Academy webinars. And I'm Tiina Parkkonen, Project Manager, and today I'm joined here by my colleague Kai Viiver, who will facilitate the session, and Inga Sipura, who provides technical support. And Kai will also be presenting tomorrow his own team education lab project. And as the holiday season approaches, we take this opportunity to explore and learn from the Education Lab joint projects, initiatives that drive innovation in teaching and learning across the INGENIUM European University. Education labs were created created to inspire new ideas and practical approaches in higher education. And their purpose is simple: to bring people together, educators, students, and partners from 10 universities to co-design methods, tools, and solutions for real challenges in teaching and learning. And an education lab is not a single location. It's a decentralized network that draws on the expertise and facilities of our partner universities. And these virtual and physical spaces enable staff, students, and stakeholders to collaborate, share knowledge, and build connections. In 2024, INGENIUM funded 12 joint education lab projects to turn ideas into reality. These projects focus on developing and spreading innovative teaching methods, pedagogies, and tools across the Alliance. And I'm sure that you feel the same, that they are not expected to be perfect or complete, these projects, but experimentation is part of the process. And today we will hear 3 short presentations from these projects, what they set out to achieve, what they have learned, and the impact they are making. Each presentation will last about 20 minutes, followed by 10-minute discussions. And please feel also free to share your questions and comments also in the chat or during the presentations. Now I'm pleased to give the floor to Kai. You're welcome.
Thanks, Tiina. So as Tiina mentioned, you all have about 20 minutes to present, and I will keep time in case there's anything. In case you get really enthusiastic with your topic and you continue to talk, I'll provide a little gentle reminder and then facilitate the discussion if we have questions after the presentation, which should take about 10 minutes, and then we'll move on. So I think that's quite enough from me. It's my pleasure to hand the floor over to the first project, which is Sustainable Development of Teaching and Learning Environments, developing the INGENIUM Learning Spaces learning community. You should be able to share your screen and start if I stop.
Morning all. So I'm delighted to lead this section of the webinar. So bear with me as I share my screen. Now, can you just let me know whether you can see my slides?
We can see your PowerPoint, not your slides.
Okay, let me just see. Now that's moving to a different screen. So I'm going to have to leave it visible like this, Kai. Is that acceptable for you?
Yeah, that works for you. If you just change the slide quickly so we can see that it's following you. Perfect.
Yeah, okay. Thank you so much. Good morning, everyone. And I'm delighted to see one of my partners here, Matty. Another partner will also join us and hopefully will partake in the presentation as well. So, delighted to be here. My name is Katie Power and I work with Munster Technological University. And I'm here today to present on our INGENIUM Education Lab, which focuses on sustainable learning environment development. So this project involved 4 partner institutions coming together. You can see displayed here the names of the partners. I myself represented MTU, HIS, TUASI and Xamk. These were all represented, and this allowed diverse experiences and learning space cultures to be discussed throughout the life of the project. So I myself was involved, as well as Peter Fogel, Matti Strengel and Professor Ankuta Rotaru. So we did have a shared goal within the project to understand how we can design and develop learning spaces that better support teaching, learning and well-being across our institutions. So here you can see the names of both the partner institutions and the individual colleagues that came together. So our core aim was to create an INGENIUM learning spaces, learning community. We wanted to share knowledge and best practices around the design, refurbishment and use of university learning spaces. So the project addressed 2 parallel dimensions. Firstly, the organizational processes behind developing physical spaces. So these are our formal classrooms, our lecture theatres, our lab spaces, as well as then our informal learning spaces within our institutions. And then secondly, the practical and day-to-day use of those learning spaces. So across all of this, we kept inclusion, accessibility, equity, and well-being at the center of both our focus and our discussions. So here I speak about the aim of the project to really bring together shared learning experiences and best practices in relation to both the refurbishing and the design of spaces. So here I just emphasize again those key points of equity and inclusion. This is from the perspective of both our learners, our students, as well as our staff within our universities. Well-being was also a key component, so addressing those well-being experiences and seeking to promote optimal well-being in the use of our learning spaces. So we did engage in multiple activities and collaboration across the project. So we sought and did establish a cross-university learning community. And so that was really central to all of our activities. We met regularly as a group, and then also invited other colleagues from our core universities. We did hold virtual workshops where we shared virtual tours of new spaces, refurbished spaces, and then we had those thematic sessions as well. So importantly, we completed 4 campus immersions and site visits. So we did have a physical site visit here in Ireland at Munster Technological University, and then we had those virtual tours across the other institutions. We collected and analysed examples of new and refurbished spaces. We also mapped the ecosystem. So considering the stakeholders when we're speaking of learning spaces, of course, central at all times will be our students and our staff, but then there's the broader core units and services such as estates, facilities, leadership, management, and so on. We integrated throughout our project sustainability, accessibility, and those intercultural perspectives. So we did acknowledge that we were coming from different institutions and settings, and of course, our cultural and our intercultural perspectives were key. So focusing again on that intercultural element, we did bring from each of the partner institutions different and distinct conceptual approaches that really enriched the discussions and experience for us within our education lab. So MTU contributed a structured framework for learning environment development. So we have that in existence, and we very much looked into that within our lab. Xamk presented a strong focus on quality, flexibility, and resource efficiency. And that was illustrated through a case study, a personas case study. Tuasi explored the concept of radical openness, its benefits, risks, and then necessary conditions for success. HIS applied participatory action research, foregrounding how users can be engaged directly in the development of learning spaces. So together, these approaches formed a shared toolbox for future INGENIUM work. I'm just having a look at the participants in the meeting. I don't see Peter here yet, so maybe he has been delayed. So I'll continue the presentation. Matty, if you want to contribute at any time, please do, feel free to do so. So within the education lab, we absolutely learned from each other and through the process of our collaborative work. So we've just set out here kind of 4 branches to our learnings. Firstly, around organizational impact. So there was undoubtedly a clear alignment between pedagogical vision, spatial design. We saw that as essential. We also emphasized within our lab that stakeholders must be included early and consistently in the design of learning spaces. So from a perspective of pedagogical impact, learning spaces must be flexible and support different teaching modes, as well as the diversity of student groups, to ensure that we're valuing agency and adaptability. Intercultural impact was crucial within our project, so different political, economic, and cultural contexts certainly shape how learning spaces are both planned and used. The diversity within our partnership expanded everyone's perspectives. And then also sustainability impact. So we saw the importance of ecological sustainability, not only reuse, but also refurbishment, and then also social sustainability. So again, those emphasis points and key points of accessibility, neurodiversity, and cultural inclusion. So we have and see lots of future potential. We do intend to continue with our shared work together, and certainly we have recommendations from within our project. So we recommend continuing and expanding the INGENIUM Learning Spaces learning community. We see we have developed a foundation for this project and within the project, but we believe there is lots of further growth that can be accomplished together. So we also emphasize that frameworks and the examples that we developed within the project can support future refurbishments and can build across the partner campuses. So the physical spaces are a key component of our teaching and learning practices individually within our institutions, but our shared approaches can, give new outlooks, new perspectives in our approaches. There is potential for a second phase project, building shared design models, or even piloting cross-institutional learning spaces. We're really enthusiastic to keep going with our work, and we are excited about what further work we can accomplish. Overall, the project created a foundation for long-term collaboration on learning environment development. We were delighted to come together at Munster Technological University in November. We hosted a seminar at MTU, and each of the partners that you see here, Peter, Matti, and Ankuta, all presented within, kind of a shared environment. So we did get to see different approaches to learning space design and practice. And it was just a wonderful collaborative opportunity. I, on my own behalf, as the lead of the project and on behalf of the partners, really do want to extend a thank you to the INGENIUM network, particularly our own institutions, for engagement across the project and also really strong ongoing support. We see this work as just the beginning. We do look forward to continued collaboration, and we will be delighted to take any questions that the audience here may have. But certainly to anyone who views this webinar subsequent to the live presentation, we would love to work with you. And so do reach out to any of the 4 reps from the various institutions. So I'll wrap up there, but we welcome questions. And I'm sure Matti might also like to offer any comments about the project. Thank you so much.
Thanks, Katie. Matti, do you have some comments, as Katie suggested,
Well,
before
thank
we move
you.
to questions?
I would like to just add that it has been really interesting project to see different types of approaches to developing the learning spaces and learn how others do this. So it's been really interesting for me to find these kind of discussions and sharing with the knowledge of how to develop the learning environments and find out about different models to do the development. So it has been really interesting, and it has been a pleasure to get to know Katie and Peter and also Ankuta, because we didn't really know before. And after we have had these kind of discussions, I feel that we have built up this kind of a community of sharing and having discussions. So it's been really beneficial project I think, for us also.
That's wonderful to hear. Do we have any questions from the audience? I have written a couple down if we don't, so it'd be great if there are any questions from the audience about this project.
Maybe I can say something. Actually, it's not a question, but I would like to say it sounds really good, this kind of cooperation, what you have been working on. And I think this Education Lab joint project are something special in INGENIUM. That way, I would really like to see that we could proceed with this kind of initiative also in the future. We did have the 2026 call for Education Lab projects again, and we are making those reviews at the moment, and they start working on the beginning of next year, but hopefully we could see and somehow make it wider, this kind of Education Lab idea in INGENIUM. I see that there is a lot of good potential. Yeah.
That's a really good point to make, Dina. And you actually just touched on a question that I wanted to ask, which was, we have these new Education Lab projects starting in January. The second round has already started last month. What advice would you give to new project teams starting their Education Lab? Do you have any practical tips for them, or things to avoid, things to do early on in the stage? What advice would you give them to make their project a success?
Thanks, Kai. I mean, from my perspective, I think what we did very well together as a group of 4 was had a very strong communication plan from the outset. So we not only engaged in those online meetings very, very regularly, but we also then had a shared team site, for sharing materials, and that was really transparent visibility, I suppose, for different projects that were going on within each institution. So I suppose when you're dealing with a project across 4 institutions, there is a risk that you might feel disconnected apart from those regular meetings. So I think if there is another route where you can support the work and, you know, just keep people engaged. I think that's a really important point. And of course, then, and I'm sure Matthew might agree, we were very efficient on email. We did keep in contact with each other. And I suppose we just had that inbuilt flexibility as well, where we understood that at times we might need to change meeting times or adapt. We each are 4 very busy individuals within our host institutions, but at times we absolutely needed to prioritize the project, and we did so. So I suppose there's an ebb and flow across the life of a year-long project. So my encouragement would be just to work together, support each other, and absolutely have very open lines of communication. I think that will really stand to the positivity within the project.
And
I
Katie,
think
that's really wonderful to hear. Matt, do you have something to comment as well?
Yeah, I think Katie summarized it really well. The communication is the key. I think that the discussions and having the communication lines open is really important to have. And I think also the meeting that we met physically, if it's possible, I think it opens up even more the communication, because you get to know the people better when you meet face to face. So if there is a possibility for that, then I think that is really important also.
Did you say that you met together towards the end of the process, or was it during the beginning? Would you advise teams to meet together in the beginning or halfway or as often as possible if you're thinking face to face?
I suppose our experience, Matty, was that we met towards the end of the project. We don't see this as the end, though. I have to emphasize that. We do see this as the beginning. We've lots more to do. So I suppose we had really built up good working relationships by the time we met in person. So I think we really optimized on that, actually, didn't we, Matty? So I suppose, look, I don't think there's a hard and fast rule in terms of when to meet in person, but I think it does bring a different element to getting to know each other. You know, I suppose there's that time for just general conversation, whereas the online meetings tend to be very, very focused. You have an hour to 90 minutes where you're meeting every 2 weeks or every 3 weeks. So they're agenda-driven meetings, but when you come together in person, you have time for more general conversation as well, which was really, really positive. I don't think there's an absolute on that, Kai, about when to meet, but like Matty says, try to make sure that you do bring variety to the meetings, however you can accomplish that.
Yeah, I think our group had the benefit of meeting online before we met face to face, so we knew about each other, what we do and who we are, and I think it made easier for us to have the physical meeting, because we had some kind of a feel who we are and what we do. So if it would have been in the beginning of the project, I think it would have taken all the time to get to know each other, and now we already knew about each other, so we could go even deeper in the physical meeting. So I think you should have at least some online meetings before meeting face to face.
Thanks both.
And I'll just, last point, we're firm friends. I do have to emphasize that. So not only colleagues, and not only do we really get to know each other about an area we're all passionate about, actually, and enthusiastic, but actually we get on really well. We're good friends. We can reach out to each other at any time in relation to the project or broader, you know, higher educational discussions. So I would really emphasize that. We've really got to know each other in terms of friendship as well. So, and thanks to the 4 partners for that. It's been fantastic.
That's really wonderful to hear. Are there any other questions from the audience? We have this rule in Finland that we should always count to 30 before speaking to allow somebody to say something, but it's always the longest 30 seconds of my life. In that case, I will say thank you both to Katie and Matti, and I can't wait to see what you come up with next. I'm looking forward to hearing more about the progress as you go on. In that case, let's hand over now to the next project, which, if I'm right, it's called INVEX, International VR Experience, which is Martin.
Yeah, that's me. Just 1 second, I have to share my screen. Go to second screen. Okay, so everybody can see my screen, or at least the slides without any PowerPoint or whatsoever?
Not yet.
Oh, great. I hope that our internet connection is stable, because here in Karlsruhe we sometimes have some problems. I just have been dropped out, so if I've been dropped out again, I'll join in a few seconds. So sorry about that. Anyway, so I'm presenting now the project INVEX, which is part of a longer ongoing cooperation between Uni Höfte and also Universidad de Oviedo, or Gijón, which is actually the location or the campus we're working with, and Hochschule Karlsruhe, together with my colleagues Enrique and Alberto. I don't know if they have joined yet, but yeah, maybe they pump into the meeting. And I also saw that one of our students is already there. So what is INVEX? INVEX, yeah, we have this international VR experience. This was actually the word we created. And the idea occurred some years ago, because I'll just show that we have an international master's program in our universities. And in this international program, we realized that our students, I don't know if it's because we are engineers, we are German or whatsoever, are quite lazy to go abroad. I don't know what are your experiences. Maybe we can talk about this later on. But in our case, we see that we offer our students more nice opportunities than they accept to really take. And of course, there's quite some challenge, and we said, okay, we have to encourage them to go abroad. And in my case, the program is EU4M, which we'll present right now. And we say, okay, you can go to the beach for half a year and study there, or even a year, and still you're not going. So I have to emphasize what you're doing. And this was back actually the idea where we started with the surfboard project, where we said, okay, here the students in Karlsruhe should get the opportunity to have a virtual surfing experience on the beaches of Asturias, which is, oh, sorry. Can you still hear me?
Just about.
Okay.
But I can't see any slides.
And now I think Martin Priest.
Let's just bear with it while we have some technical difficulties.
Yes.
Welcome back. I can see you.
Sorry, our internet is a mess. I don't know why.
No
I don't know
worries.
what you've heard in the last. Can you still see my screen now? No.
No. If you could try resharing.
Okay. Sorry.
There we go.
Okay. So now you can see it.
Yes.
Okay. So here you can see again our vision. That's the student here in cold Germany standing on a parallel kinematic robot. And on this parallel kinematic robot, he wears VR glasses, and he not only experiences the 3D vision, the 360-degree vision of the surfing experience that the surfer in Asturias is having, but also he is experiencing some accelerations that have a deeper immersion into the whole thing. So that's the vision. And let's go to the partners. Partners are partners of the Master EU4M, which is a Erasmus Mundus Master, which has also been partly founded out of INGENIUM. So we have existed earlier on, but only when INGENIUM started, we gained our friends from Höfte. And we have a long ongoing cooperation with Gijón in Spain, which with Universidad de Oviedo and Hochschule Karlsruhe. And we also have a third partner, which is not part of INGENIUM, which is NZEM Submicrotech, which is Grande École in France. And the project is, to be honest, going on for more than 1 year. You will see that within the development of our vision, we had quite a lot of work. And yeah, so this is only part of the lab that we just implemented into the technical lab. But as you can see here, it worked out. So what you can see here is actually working together of students. One of them I saw is here, which is Meron, the guy in front here, that from all the 3 locations. So Meron and Moritz are students from Karlsruhe, have been going to Höfte, and now you see them in Gijón, working together with other students, Swedish students coming to Höfte and Spanish students on the project in the lab in Gijón. So we, as teachers, did not already knew each other, but we also wanted to get the students connected. And this is why a few weeks ago, they had some actual working together physically in Gijón, in Universidad de Oviedo. So you can see more student work here. Work is here a nice word, because here is our measuring student. That's actually Moritz, one of the Karlsruhe students going to Asturias, experienced the surf he himself. And on his head, you can see he has a helmet, and on the helmet mounted, he has a 300-degree camera, which we purchased. But the other part you can see on the slide, which is the electronics. This is something this was really developed within student projects and by the students actually in this technical lab, in this education lab. And they developed the measurement equipment, combining various sensors, making their mind up how they can synchronize the camera images with the data recorded by the IMU, which is the initial measurement unit, which is measuring accelerations and also inclinations of the body and so on. And they developed the actual electronics, or put together the electronics parts, and which was the bigger challenge, also had to get it waterproof. As you can see here, with the first measurements they had some problems, because they are working in a really harsh environment. You know that when a wave is breaking, there are quite some forces acting. And the first device they just developed wasn't waterproof. And this is now something which is ongoing work. So they decided now to dig a little hole into the surfboard, let's say, and have then a more waterproof connection of the electronics for the next measurements. But nevertheless, they already got some signals. So you can see here the first data acquisition results they just submitted. It's not already perfect. We have to go on with doing more measurements, but this is already really helpful for us, because now we know a little bit, have some input material that we can start to create a pipeline with it, because it's actually a challenge now from these raw signals down to really steering the parallel kinematic platforms. And this is something that is already going on in the project. So we have some filtering to do at first place, but not only filtering, we also have to shift data from system to system. You saw here the board with the integrated circuits, and now this has to go onto a computer. Also, this computer was developed, or at least mounted within the project. So also the The parts were purchased also on funds of INGENIUM, so thank you for that. And our students here in Karlsruhe put it together and set up a computer and software. Here you can see a short excerpt also of this software for data analysis. So they already programmed some graphical interfaces that we can put the data later on for further processing. Yeah, the further processing here also thanks to the guys from Sweden, they set up a nice picture how you can imagine the whole process. So on the left you can see the camera with the surfboard. So this GoPro is actually mounted on the user. You saw it on Moritz, and on the surfboard you also have this the measurement unit, which is the IMU, and also processing electronics. And this now gets stored then on our VR computer, where we then have to do some kind of post-processing, because as I said, we cannot directly shift our data on the platform, but we have to find, and this will also be part of further developments, we have to find a right translation of the signals. Anyway, then this whole thing is connected to the VR classes. So then we will transport also the camera recordings to the classes. And as I said, the other data via Ethernet also to the drives. And here you can also see we already started also some programming within the VR section. We also have created a menu to select different options like starting it, the videos, repeating it, preferences, and whatsoever. Then this is a thing that now the Swedish students have been working on when they were in Gijón together with the students from Karlsruhe and Spain. We also created the digital twin within Unity. Unity is the colleagues from Sweden might know it. It's a software for game development, actually, that we use in Sweden and also in Karlsruhe for the VR environment, because it's quite good software there that you can also, if you don't use it commercially, get really cheap. And there we produce the digital twin that might help us in the further development of the system. So as I said, one of our main problems is the connection from actual measurement signals to actuation signals of the drive, because we have now a parallel robot with 4 degrees of freedom. We can move up and down, and we have the 3 rotations. And with these 4 degrees of freedom that we have on a parallel kinematics, we have to implement the 6 degrees of freedom of the actual user, which is experienced on the surfboard. So for example, if we have some accelerations, we have to do some inclination of the board or something like that. And it's not one-to-one what we have measured. So this is something that we want to do in the next semester. We want to get algorithms that make these translations. Maybe that the degree of freedom is not implemented really on our systems because we are lacking it, or also things like, yeah, if for example the surfer is doing a turn, then he might experience centrifugal forces that inclined surfboard on our lab doesn't have, and the user might fall down, and there's still some work to do that we might also test with a digital twin so we don't get harmed in our lab. So what else? Let's speak a little bit more about mechatronics. So our master that we are teaching together is actually a mechatronics master. And so also our students had quite some interesting work for the mechatronics to do, because they set up also the whole drive section, and this was quite challenging. We were really happy that, for example, you can see here we have 1 rotational drive and 3 linear drives. There was also some present from a company where we got the linear drives, but then the next thing is how to communicate with them. And I had, for example, 1 student group who was fighting a lot to find out the communication protocols, which were suitable because we were working on the computer on MATLAB to connect MATLAB output signals with these drives. And this was really challenging because they faced real world problems like bad or lacking documentation of what is really happening within the drives. We had to talk to other colleagues, and this was quite a tough matter. For the rotational motor, the same happened. We had a motor which had actually things inside which weren't in the manual, and also there we had to fight hard to get the whole thing working. How is the whole thing set up? So we're starting from the VR computer, which is connected via Ethernet through a router. We have our personal Wi-Fi there, which is not a Wi-Fi connected to the internet, but just a lab Wi-Fi. And this lab Wi-Fi is now going to the microcontrollers you can see over here with motor shields. And these motor shields are then connected to the drives with the CAN bus system I just spoke about. Then there's something else. You see there's also a connection to mobile phone. You might think, what is this? This is not actually really important for the actual project, but we have some further visions. There are also games like, people from my generation might know Tony Hawk's, or for the surfing, there's also a game which is available for smartphones where you can do surfing. And then the further steps, we also want to use the IMU maybe from a mobile phone, so that the person actually mounted on the platform can steer the platform by moving its body. And this was also a useful feature in with respect to testing of the platform, because what we also had to test was how was maybe I just go to the platform, how's the feeling on the platform. We have there inverse kinematics developed that allows us to have an inclination about 13 degrees, which sounds really little. 13 degrees sounds like nothing. But when we were standing on them, we found out that 30 degrees is quite a lot. So you nearly fall down. And for this reason, also this IMU was quite useful, because then we could test several inclinations and also the user experience. So this is why we have this additional connection here for testing and further purposes. Yeah. The development of the platform actually was also a long ongoing process. To be honest, I'm been working for now a few years on it, and that's why we always find something to improve. The thing we actually improved was within this project phase was that we saw that there's we had in the old design, we had too strong bending forces on the connections here. And this is why we had to redesign the struts here. And we nearly mounted them. So we also got support here from a company which is called Schaeffler near our, that also has students with us. And they really supported us a lot in get the whole thing mounted. But when we mounted it, this is why I can't show you the system as a whole. We found out that we had again a defect in the drives, and we have to send it in again. So also this is ongoing work, but we have now a really nice design where we could decouple the bending forces actually acting on the platform and the translational forces, let's call it. So what else? A lot of few things we had to do. We really underestimated it a little bit when we started the product development on how many points we had to work. Things like when you look at the top of the platform, you see that there's a rotational platform, and we thought that this might work with the brake of the motor. It actually didn't. We had to design actually a pneumatic brake in addition to the motor, so there is no damage in the system, and also the people when they mount can get a stable first step on the platform. when it's not switched on yet. Or something like electricity, we started with a few cables and converters and whatsoever. And at some point we said it's getting too dangerous. We really need to design an electrical cabinet. And also we were really happy with our students. We had one student before he joined the studies. He also worked in as a professional with electrics, let's say, and this, as he had a professional education, and he really helped us to get the whole thing done. Also, including, you can say it here, with safety bottom and some things on. So it's really, yeah, really product development, and we could include now in the bigger project with the partners, students from all 3 locations working together, and this was really a nice experience, because then they also had to experience what they have to do later in companies. They have to do their online meetings and find out through online meetings what is the problem at the other partner. They had to get to know each other, finding ways to work together. And I think that's really a plus to just a project going on in just one institution. And we could really also include it into the regular curriculum. So now the students get marks. Also, my students will get marks for what they did in this project, and they will be accepted as a regular grade within their studies. Yeah, our experience about collaboration, as you just mentioned in your project, it's all about people. I think especially international collaboration, it is important to get to know each other and to get a basis of trust. And in our case, I think it's also, we got a basis of friendship because we know each other also from the master. And this really helps, because projects with people who are far away also tend to fly away, because you not really meet your colleagues in the hall and they ask you what is happening on this project and so on, but you really need to get focused and stay in touch, and this is also one of the experiences. And we will go on with this cooperation. As I said, we are working together in master, and as I say it here, SurfRobot will continue. We have still quite a lot of things to do. We have to finalize our IR hardware. The VR pipeline is already there, but it has to be filled with real data. So the students in Gijón will have to do some more nice surfing there. And of course, one topic we haven't talked about is safety. So there's a big issue we still have to solve, which is usability for users on this platform wearing VR glasses. There might be a huge safety problem. At the moment, we are working with climbing ropes. So the users on the platform are just wearing climbing equipment, and another person is standing there waiting every second if somebody falls, because I'm really afraid that somebody will be destroying his leg, because if you don't see where he's stepping, this might really be dangerous. And there's something we have to do in the future. And as I said, the measurement, the conversion of measurement data into actuation data. So we will have work for the next few years, but I'm really looking forward to implement this work, because it's really a pleasure to work together with my colleagues from Sweden and also from Spain. I see now Alberto is also here. Maybe, we can introduce ourselves. And thank you for listening.
Thank you so much, Martin. It was wonderful to hear more about your project. Before I ask questions, you mentioned that Alberto was here. Does he have anything to say about the project? How did it go from your perspective? We can also take questions.
I think he's still fighting with the hardware. So go on with your questions. Maybe you can join in later.
Do we have any questions from the audience? I'm doing a mental countdown in my head now, but it appears not. Please just ask if you do have any. So I have some practical project management questions. You mentioned that this was a sort of already existing idea that you started working with that you then turned into an educational lab. Can you talk a little bit about how you managed that? How easy was it to turn this idea into a INGENIUM project?
It was actually the ideal platform because you are now fostering people who want to work together over several INGENIUM institutions, and this was already our idea. So as you have seen, this was a lot of work. This was not feasible within 1 year with a few students. And we had to go to the point where we now more and more included the partners from Spain and Sweden to get the whole thing running. And as we were celebrating last year the graduation of our former EU4M students, we were thinking that the INGENIUM lab educational lab might be the perfect platform, and then we applied.
That's wonderful to hear. Have you planned your follow-up projects yet?
We will go on, but to be honest, I missed the deadline. We didn't apply for another INGENIUM project.
Well, these things happen. I have a couple more questions, but is there anybody from the audience yet? Appears not. So I'm also curious that you mentioned that you had a non-INGENIUM partner in the project. Was there cooperation between the other INGENIUM partners and the partner from industry? Did you all work together?
The industry partner just supported us. So we got support from industry partners via parts. So we got the drives. They were from this company Linux. So the students wrote them and said, "Oh, we need your drives." And I said, "Okay, you get them for free." This was really wonderful. Now, as times are getting harder for the inspection, when there was something damaged, they wanted money, but in the first place, they really gave us the drives as a present, and also for the mechanical parts, the manufacturing of the mechanical parts, we got support from Schaeffler, but they were not really as a partner in the project, as working together with us, but just supporting us by hardware.
Sometimes it's the best way.
Yeah, it is.
So I also have the same question that I asked to Katie and Matti earlier. What would you do differently in terms of running the project if you were to run it again?
Don't know what we would do differently. So,
or what advice would you give to new INGENIUM education labs starting?
Get to know each other because before start working together. So it was really helpful for me that I knew Alberto and also Enrique in person before we started working. This really helped a lot. I know it's not always
how
feasible.
You met them before?
I met them because of EU4M.
Brilliant.
Yeah. So we were an existing consortium, and this already also helps. So I think use INGENIUM. I mean, you can have your stays abroad financed by INGENIUM. There's a lot of possibilities to get to know each other because, as I said, collaboration is about people, and if you don't are good connected to the people, it doesn't work.
Thanks. Are there any final questions for Martin before we move on?
No, thank you. It was really interesting case once again.
Thank you.
Wonderful.
Great. And I see our next presenter is already here, which is we're talking now about Internet of Things driven environmental monitoring for innovation sustainable education, which is Shaquille from Xamk.
Hello.
Hi
everyone.
Are you able to share your screen?
Yes.
Fantastic.
Let me try. Yes, let me know if you can see my screen.
Yes, we can. Brilliant.
Okay. Okay, great. Thanks. Thanks, Kai and Tina for organizing this. And so today I am here to talk about IoT-driven environmental monitoring for innovative, sustainable education. And we are doing this project in partnership with MTU from Ireland. And my name is Shakil Regmi from Xamk. I am teaching in a degree program of Bachelor's of Environmental Engineering. And now we have also started Bachelor's of Water Technology and Sustainability. Basically, it's the upgrade of environmental engineering. And we have a lot of topics related with environmental monitoring. And at MTU, they have a lot of topics related with sensors. So this is where we thought we will collaborate together and do this interesting project. So let me talk about it. So the background or the main objective here is to develop sensors for environmental monitoring. And the main idea came because when we are doing environmental monitoring, environmental sampling, these types of different projects, then mostly the sensors are really, really expensive. So I just remember that in the month of October and September, we are going to the field and doing some analysis of river flow, and the device we are using costs around 20,000 euros. But with the modern low-cost components of sensors, we can do that for very less amount of money in a fraction of cost. For example, around 200 to 300 euros. So this is where we are combining our ideas. Then another point is long-term uses of the sensors, because when we are going with these expensive sensors into the field, then we are only collecting the data on the spot, and there is not much we can do in terms of long-term observation. So that was the second point. And of course, the third point was also the educational value, because we are mostly utilizing these pre-made store-bought sensors, which are really expensive and really fragile also. The maintenance is quite high cost-wise. And when students are working with it, they are not able to understand the basic functionality about how this type of sensor is actually working, how it is collecting carbon dioxide data, or how it is collecting air, water quality data. So all those things were a missing gap. I was having this discussion with the students for some time, and the concern that they had was they also wanted to understand the background story about how these sensors are working. So luckily, the INGENIUM project call for proposal came in last year, and we applied for it through MTU and through Xamk. In MTU, they have the Bachelor's of Engineering in Sustainable Energy Engineering, where they are focusing mostly on energy topics, but they also have a topic of sensor in there. And at our program, Bachelor's of Engineering in Environmental Engineering, we talk about environmental monitoring, environmental sampling, and those kind of things. And sensor is something new for us. We are moving towards that direction. So we thought this is a good opportunity to combine our expertise and at the same time to combine our students so that they can learn from each other, and at the same time they can work on this project jointly. So overall, that was the project. So the importance of the project comes in the low-cost sensors. Like I mentioned earlier, we are now building low-cost sensors, really low-cost sensors. For example, for a normal air quality sensor, if you spend 5,000 euros, then you get a good quality sensor from the store. But if you do it by yourself, maybe 200 or 300 euros, and that has been quite valuable. And sensor deployment, this is another important point, because you cannot get long-term data. So if you do not have long-term data, then you cannot make long-term environmental observations. And that has been quite important and interesting, because we have a lot of project works and and courseworks where these types of topics are discussed, water quality and air quality. But what can we do when we just have one point of data? That was the question. So with these sensors, there is firstly less risk. When you put something which costs 10,000 euros in the field compared to 200 euros, relatively, there is the value there. Another important point is the reliability of these sensors, which we have tested and calibrated against these expensive sensors. At the same time, against the values that we calculate in our lab works, and these sensors have been quite accurate. So that has been quite important. And thirdly, the educational value is that the students can actually learn how these sensors are developed, how to deploy the sensors or install it, how to collect the data, how to process the data, and how to analyze the data. So this connects the idea of sensor development, then data collection and data analysis. So the data analysis also becomes part of this entire package where students are learning this, because field related with energy and fields related with environment these days, they are mostly related with long-term data analysis also. So that has been quite important. And like I mentioned, both degree students, they develop the same sensor. Basically in Xamk, we are developing 9 sensors, and in MTU, they are also developing exactly the same 9 sensors. So the students are developing it together, and it will be deployed in Xamk, and the batch in MTU will be deployed in MTU's campus premises, and the data will be shared amongst ourselves. So that means students from Ireland can see air quality data from Finland, and students from Finland can also see air quality data from Ireland. So there is also this environmental aspect where we are discussing about air pollution and those kind of details. So that has also one extremely valuable point for us. And this process has been really, really important, basically the collaboration aspect, because we do not have all the specialties, and based on our discussion in MTU, they also do not have all the specialties. So when we combine, then we have added value for both of us. So that was really, really nice. That was really, really interesting. Another important point was lowering this cost of the sensors and reducing the footprint of sensors, both in the aspect of cost and also in the aspect of economy, because the size of these sensor packages that we have after developing this is really, really small. So that has been really, really helpful. And students are working on this based on a project. So they have a project which is part of a course, and they work on it and they complete the course. And it has been quite interesting because we also have a course which talks about sensor and environmental monitoring, and in MTU they also have a course related with sensors. So basically this project fulfills the requirement of these 2 courses also, so we can work hand in hand on these courses. So about the method part, firstly, of course, there was this discussion of idea and what to do and what not to do, because environmental monitoring is a very broad topic. So we focused it down to air quality sensors for environmental monitoring. Firstly, this was because of the course that we have here in Xamk. We have a course called Air and Biological Sampling, where we are doing air sampling related issues. And at the same time, in MTU also, they have a course related with sensors. So both of the courses matched. And there was a keen interest in the air quality also from our partners in Ireland at MTU. So we are exploring and analyzing different indoor air quality parameters, for example, carbon dioxide and temperature and relative humidity, etc. So I'm always giving this idea or statement to the students that when you are inside a classroom and you are listening to the lecture, Then if you are feeling a bit tired, if you are feeling a bit sleepy, it's not because the lecture is boring, it's because there is more carbon dioxide in the room. So just open the window so we can actually test this theory or statement that I have been giving in the last few sessions. So basically, air quality sensor has been our topic. The next step was to finalize the sensor and components of sensor. So what to buy, where to buy from, because we want to build exactly same thing in Xamk and also at MTU. So based on that, we designed the architecture of the sensor, so how it will work and what to add, how to add, all those details we worked upon, because this was relatively new topic for all of us, but at the same time, really, really interesting topic. So the green part, which you can see on the upper part, it has already been completed. Now the remaining part is the project-based session for students, where the students are actually developing and working on it. So we already have the guideline and the objective of the course, and I will talk about it in a while why we are waiting to do this. It is related with our course timing, but basically the remaining part is where the students are working on this project as part of the course. So about talking about the achievements or result, at the moment we have finalized all the details about which sensors and how they will be developed and how they will be assembled, basically all these components, how they will be assembled. But we have already done one test of air quality sensor in the context of particulate matter. So what is the amount of air pollution? And it's a very simple setup where we have a Arduino board, which is connected with particulate matter sensor and also with a Wi-Fi module, and we program it. And then the sensor is able to send the particulate matter data based on the setting that we provide. So for example, at the moment, when we did this testing, the setting was every 5 minutes that the sensor should send the data over a cloud, which is only for trial purposes. We used a free cloud, and on the right hand side you can see the result, how it is shaping up. Basically, we are able to track what is the particulate matter 2.5 of the air in the classroom. And this has already been really interesting, because earlier when we had very limited time. Our lectures are 2 hours or 3 hours, so you can only do this type of observation for 2 hours or 3 hours when the device is available, and it is quite a heavy device with a lot of wires and all the related components. But this is such a small device, and you can just switch it on, plug it on, and then just leave it there for it to collect the data. And it has been quite fruitful. So when we are sharing this type of data or first initial observation with the students, then the students are also actually quite interested and further motivated about this. The setup is quite simple. This is only one parameter that we have analyzed, and it's basically an Arduino board connected with particulate matter sensor and with a Wi-Fi module. But in addition to particulate matter, we are also adding carbon dioxide, relative humidity, temperature, volatile organic compounds, nitrogen oxides, and air pressure, and GPS for location. So these are the things that we are finalizing at the moment. Also, one more achievement is that we are now able to develop these 9 sensors with approximately 1,400 euros. And if you think about conventional sensors that you can buy from the store, then maybe for these 9 sensors, it will be most probably 10 times more expensive. And we have such sensors and such equipments at our lab. But again, those equipments are very expensive, very fragile. And like I mentioned, long-term monitoring is quite complicated with these. So it has been quite fruitful, and it has been a learning process on both of our side, MTU and Xamk, where we are trying to combine ideas and bringing it together. So About some timing issues, it took some time to prepare, of course, because the idea was quite broad and the possibilities are also quite broad. So we had to find the exact topic which fits our common courses, because we also cannot afford to do something extraordinarily new. So we wanted to see where we have the where we could actually value add to our ongoing courses or our ongoing program. And to finalize all these things, actually it took some time. Then also the course timings was also crucial, because our courses, these two courses are organized during the spring. And when the project started during the spring, then basically we had to wait for some time until the same courses are organized in the upcoming spring. So this is when we will be doing this project work with the students actually. But the preparation and the finalization of the topics are already ready. And that's good news actually. So like I mentioned, because of the project timing and because of our course organization, that played a role. Then another important and really positive thing was that which I mentioned a few moments ago also, is that we are specializing mostly in environmental monitoring, and at MTU they have more specialization about sensors. So that has been a very good match. And since we are also moving towards developing more low-cost sensors to be more independent from those large sensors, it has been quite an important aspect. And about the collaboration, yes, I think in the beginning it was quite challenging, because we had not met, or we had not known each other. And when there was this this call for proposal, we started exploring potential partners, because this idea was already floating in the head, at least in Xamk, in our unit, since some time. And when we started to explore and talk around, then we found a potential partner with MTU, which has started quite well. It took some time, of course, because things were new. And like Martin mentioned earlier, that you need to really know people, you need to really talk with people. So that also took time, which has been really, really fruitful. And we really see continuing this type of work in the future. So overall, that is the situation update and work that we have put into this project. And with that, I would like to end it here. And if there are any further questions or any points that you would like to discuss, then I would be happy to discuss further. Thank you.
Thank you so much. That sounds like a really wonderful project. And I would be super interested to find out if you actually put this into practice and test the air quality of some really boring professors to see if it is the air quality making people sleepy, or if it's
Yeah, I
them.
think yeah, I think it's not the lectures. That's what I have been telling to people, but let's see.
Yeah, and you should have the data to back it up now.
Yeah.
But do you have, not you, sorry. Are there any questions from the audience? I have a couple that I would like to ask. Tina, do you have anything, or?
At this point, I do not have any questions. Maybe if something comes up, I will ask.
Anything from the audience? Okay, I just have a couple of very practical questions. The first one was, you mentioned that it was a little bit challenging in the beginning to get the cooperation started because of the time constraints and the fact that the project started in March. Could you open this up a little bit more?
Yeah, because yeah, the challenge that I mentioned was associated with the type of courses we have, and the courses are actually organized from mid-January to end of April. So when the project started in March, then there was less opportunity for us to, react as quick as possible. So that's why we have to push the project a little bit far away until this point, and maybe until upcoming spring also. That was one aspect. Another aspect was, I think, it was only related with finding potential partner, and that's a normal thing, I would say. So other than that, once we finalized everything, then it was more easier. So I would say it was kind of a natural process overall, because we found our partners, we discussed the idea, then we finalized. Then when we saw the potential timing, then that was the only possibility. And also one more thing that I could add is that because most of our schedule planning is already done during November or December. So for example, 2026 is already planned. And when the opportunity of project is finalized in March, then it became a little challenging on both the sides to find extra hours to work on the project. So that was the part, but I think it's not a negative problem, right? It's a positive problem to have more work and interesting projects. So overall, all good.
Yeah, that's wonderful to hear. My other question would be, what advice would you give to new project teams starting their education labs in January?
Yeah, I think I would like to, kind of repeat what Martin said, that try to talk with people or with your partners, have some sessions to get to know each other. I think that is really important, and that has been helpful for us also. In the beginning, when things are a bit unclear, after a couple of meetings, then things are already a lot clearer. So I would suggest having more discussion, because technical aspect, I think when you have written down the project proposal, then you are certainly confident that you are able to do this type of technical work, but the communication and those types of work, I think that is also real work. So I would suggest to have maybe some, session organized by INGENIUM itself. For example, today, this kind of session, because when you have to do it voluntarily, sometimes you miss because there are so much work. So if there is something that you have to attend and do, then I think that could also be valuable. I don't mean to force ideas, but maybe that could be one way. But maybe you know better.
No, that's a great suggestion. Thank you. Are there any final questions?
Hi everyone, my name is Peter, calling in from Skövde. I was curious about how you if you find any cultural challenges. And I mean that perspective quite big. Can it be country-wise or discipline-wise, or like this?
Yeah, country-wise, we didn't feel much of a difference actually, because the working culture, I think it was quite similar between Finland and Ireland. At least that's what we felt, the way we were putting in our work. In the context of the topic, maybe this was something a bit challenging, because we are mostly working on environmental topics, environmental monitoring, and we wanted to go towards sensor. But in Ireland at MTU, they have already been doing things related with sensors, but they have not done things related with environmental topic. So that was one gap where we had to discuss and come to a common ground, that what actually means environmental monitoring for us and for them, and how it could add value to them also. Because if we would have said we want to do water quality analysis, then maybe it would have no value for them, because they are not working on that field. But when we have indoor air quality related topic, then it was a common value. So we found a strategical solution in that sense. But in the context of cultural work differences, I think there was very minimal things to even notice or discuss.
Thank you.
Thank you.
Thank you so much. I will just share my screen one last time. So thank you to everybody today for coming and talking about your projects. It was really wonderful to hear more about the different educational lab projects you've been doing over the last 9 months with INGENIUM. We hope that the cooperation, as many of you have said, will continue and lead to new possibilities. We have one final webinar tomorrow between 12 and 1:30 Central Summer Time. Yes. And we hope to see you there. On behalf of everybody at Xamk, thank you so much for joining us today, and we look forward to seeing you again soon.
Thank you.
Thank you.
Have a nice day.
Thanks for organizing this. Thank you.